Welcome, students. In this video, we are going to solve the following worksheet on section 1.3 on limits at infinity. So let's start. Here we cannot use our limit for ratio of two functions right away, since a limit of numerator goes to minus infinity and limit of denominator goes to plus infinity. But we can divide both numerator and denominator by t to the power of 1.5. So we'll end up with minus 1 plus 1 over t to the power of 0.5 divided by 2 plus 3 over t to the power of 0.5 minus 5 over t to the power of 1.5. So these terms here are going to vanish as t goes to infinity. So we'll end up with minus 1 over 2. Okay, next problem. So when you see problems of this type, try multiplying numerator and denominator by conjugate, which is going to bring us to the following expression: limit as x goes to infinity, 9x squared plus x minus 9x squared divided by root of 9x squared plus x plus 9 plus 3x, since we are multiplying and dividing by conjugate. All right, so then we'll end up with limit as x goes to infinity of x over root of 9x squared plus x plus 3x. Now dividing both numerator and denominator by x, we'll end up with the following limit: 1 over, so when we divide the square root by x, it is safe to bring x inside of square root, since x goes to plus infinity, so this is positive. So we'll have 9 plus 1 over x plus 3. So as x goes to infinity, this term here vanishes, so we'll end up with 1 over 6. Okay, next problem. So values of sine squared x when x goes to infinity are going to oscillate in the following interval from 0 to 1, and denominator blows up, goes to infinity. So the answer here is 0. Okay, so next limit. Numerator goes to infinity, and denominator sine of x is going to oscillate between minus 1 and 1. So since we don't know, we'll end up with, obviously we are going to end up with plus or minus infinity. So the values of this function will oscillate between plus and minus infinity, but we don't know the sign of it, so this limit doesn't exist. Next limit, as x goes to 0 from the right-hand side, we know that ln of x goes to minus infinity. So this expression here is minus infinity. Then if you recall the graph of arctan of x, graph like that, and as x goes to with horizontal asymptotes at minus pi over 2 and pi over 2. And as So let's assume that we made a substitution here. Let's call an ln of x as theta when x goes to 0 from right hand side, theta goes to minus infinity, as we said. And when theta goes to minus infinity, inverse tan of theta goes to our asymptote at minus pi over 2. So the answer here is minus pi over 2. Okay, next problem. So 1 minus e to the power of x. We can divide both numerator and denominator by e to the power of x. We'll end up with limit as x goes to infinity of minus 1 plus 1 over e to the power of x divided by 2 plus 1 over e to the power of x. Okay, so the answer here is minus 1 over 2. Okay, next limit. Here we can divide both numerator and denominator by x cubed. We'll end up with limit as x goes to minus infinity. So we have to be careful here, since x goes to minus infinity. We are going to divide both numerator and denominator by absolute value of x cubed. So we divide both numerator and denominator by absolute value of x cubed. Now, since this is positive, we are safe to bring it under the square root. We'll end up with 9 minus 1 over x to the power of 5 divided by, so when x goes to minus infinity, this is negative. So we'll open our absolute value sign with minus. We'll get minus 1 and minus 1 over x cubed. Okay, now as x goes to minus infinity, this is 0, this is 0. The answer is minus 3 then. Okay, now arctan of e to the power of x. As x goes to infinity, this is infinity. This goes to infinity. So if we recall our graph for arctan of x, we have horizontal asymptote at y is equal to pi over 2. So as theta goes to infinity, as this goes to pi over 2. So the answer is pi over 2. We can solve this by substitution. If we write down all the steps that we did right now, it will be of the following form. So our first step, we made a substitution e to the power of x, let's call it theta. Then as x goes to infinity, theta goes to infinity. So this limit here is transformed into the following limit as theta goes to infinity of arctan of theta. So this goes to pi over 2. Okay, next problem. That limit here reminds us of the following limit. Limit as x goes to plus or minus infinity of 1 plus 1 over x to the power of x. So this limit is equal to e. Let's try to bring this limit here to this form. We can express that 1 plus 1 over minus x over 2 to the power of minus x over 2. But we also have to then raise that to power of minus 2. All right, now here we know that limit is equal to e, then our answer would be e to the power of minus 2. But if we were to write down all the steps that we did here, we can use substitution, introduce t, which is equal to minus x over 2. As x goes to plus infinity, t goes to minus infinity. All right, so this limit here is transformed into limit as t goes to minus infinity of 1 plus 1 over t to the power of t to the power of minus 2. Now, using limit laws here, since that limit exists, is equal to e, we can move the power across the limit sign. So this is limit as t goes to minus infinity of 1 plus 1 over t to the power of t, that limit to the power of minus 2. So this is e, and we'll end up with e to the power of minus 2. Okay. Okay, next problem. Limit as x goes to 0 from negative side of e to the power of cosecant of x. So we can express that as limit as x goes to 0 minus of e to the power of 1 over sine of x. Now, let's take a look at the value of sine of x as x goes to 0 from negative side. Let's draw a unit circle to help us out. As x is approaching to 0 from negative side, the value of sine of x is going to be some small negative number. 1 over some small negative number is going to give us minus infinity. Right, so we have e to the power of minus infinity. So this is 0. We can again express all of our steps using substitution. So let's write that down one more time. This is limit as x goes to 0 from negative side. Let's replace that with t. As x goes to 0 from negative side, we said that 1 over sine of x goes to minus infinity. So t is approaching to minus infinity. So let's replace that with t. And we'll end up with e to the power of t, which is 0. Okay. Next problem. Using laws for natural log, we can express that as the following sum. Then we can divide everything by ln of x. So we'll end up with ln of 2 over ln of x plus 1 over ln of 3 over ln of x plus 1. So the answer is 1, since those two terms are going to disappear as x goes to plus infinity. All right, guys, now this problem here concludes our review on worksheet on section 1.3. Thanks for watching.